Okay, here is my solution for the problem that we did on Friday of week 4. And we were looking at calculating the coefficient of static friction. And so the problem was that if we take a ramp with a block and we change the angle, we can change the angle of the ramp up into the point where the block finally just begins to slip down the ramp. This is called the just slipping condition. And we know that it just slips when the force of friction is at the maximum force that static friction can provide. You should note also, too, that once it starts, it will keep going. Because the force of kinetic friction tends to be less than the force of static friction as a max. Okay, so that was from last problem, but this problem was simply about that critical angle. And so if you imagine that you do this experiment until it just begins to slip down the ramp, we can call that a critical angle. And the question was to find mu sub s. Okay, so I'm going to start with a free body diagram, like I always do. And so we have the normal force going this way, and the static friction force is going this way, because it always opposes the motion, and downward is the force of gravity. I'm going to choose coordinate systems that go this way, and so that means I have to take the gravity force and separate it into components where this angle is theta. And so the sum of the forces in the x direction is equal to mg sine theta. That's this force. And in the negative direction is the force of friction. And that's it. The sum of the forces in the y direction is equal to the normal force minus mg sine theta, not sine theta, cosine theta. That's this side. And that's equal to all of the forces in that direction. Now, Newton said that the sum of the forces in the x direction has to be equal to the mass times the acceleration in the x direction, but it's actually just about to slip. So far, it's not accelerating. Just barely, but it's not accelerating in either the x or the y direction, of course. It doesn't accelerate in the y direction because it doesn't leave the ramp. So the definition of mu s is the ratio between the max of static friction to the normal force at that condition. And so I can solve the top equation for the force of friction, mg sine theta of the critical condition, and the normal force is mg cosine theta critical. Doesn't depend on the mass or the strength of gravity, actually, but mu s is then tangent sine over cosine theta critical. And that's the answer.